vamos a llamar aquí a nuestra Keynote, nuestro querido Chris, que él es de la CNCF, director de la parte de toda la parte de la Cloud Native Foundation, y está con nosotros hoy día, que ha viajado para podernos dar esta charla y nos hablar de toda la parte de las comunidades, LATAM y Open Source. Bienvenido, Chris. Welcome, Chris. Are you?
It's good to see everyone here. My Spanish is unfortunately not so good. Entiendo español poquito and español de cocina, yes. But it's been great to be in Peru, trying many things. I was de probar pisco por primera vez ayer, which was very good. So it was nice, yeah. So, but but. My Spanish should be better by now for sure, but for this technical keynote and talk, we're gonna speak in English, and I will do my best to speak slowly, and if you have any questions, feel free to flag me down. So today I'm gonna talk a little bit about kind of the history of where Cloud Native came from, how you all could get involved in the CNCF and Cloud Native community. So to kick things off a little bit, the CNCF, we are one of the largest global open source foundations out there. We have over 190 projects that we host. Many of you may be familiar with Kubernetes, but we host Prometheus, Linkerd, CNI. There's so many different projects that we host all across our organization that really encompass the cloud native stack. We have 240,000 contributors that contribute to our open source projects like Kubernetes from 193 countries worldwide, representing, I think, about 9,000 companies or organizations worldwide too. So it is a very global, diverse community. Our mission is very simple. All we want to do is to make sure projects like Kubernetes, Prometheus are sustained, available for everyone. So whether you want to run these projects at home in your lab, or if you are a bank or a cloud and want to provide a service, we want to provide it for everyone for free at no cost, and make sure these projects are sustained. So I want to give a little history lesson for maybe some of the folks that are a little bit younger in the room. I see a lot of students here, which is fun. If you kind of look at the history of computing, I mean, you could go way early back to kind of the 60s and the inventor of the transistor. But if you kind of look at computing in general, most people about 25 years ago, when they wrote applications, they did it on non-virtualized hardware, sometimes mainframes. Some of you may have heard companies like Sun, back in the day, or DEC, and you basically had a single tenant machine where you just wrote your application and everything was kind of shared on that. It was non-virtualized. What eventually happened was virtualization was invented and popularized by VMware. So a lot of people are running VMs now still all over the world. We then kind of evolved where Amazon came out and basically invented computing as a service, or cloud in some ways. They basically started with EC2 and S3, which are still really the most popular services out there. Other private companies, started to invent new things like PaaS. Heroku really popularized the concept of platform as a service, which makes it easier to write applications in an opinionated way. Then we started to see open source versions of these things. So OpenStack was really the first attempt to do an fully open source kind of EC2 with Swift and kind of the storage open source project had, Neutron with the networking bits. Then Cloud Foundry tried to popularize open source PaaS, right? Then 2013 comes along and Docker comes in and really, they don't invent containers, but they popularize containers, right? And then CNCF, it's going to be our 9-year birthday later in December. We really came together to really popularize the notion of cloud native technology, of basically fully open source, so you could build your own cloud, stacks that are fully observable and so on. So if you kind of look at this history, it's been basically a march of moving from non-virtualized hardware to very, piecemeal, containerized, software that, talks together, that is resilient and so on, that is also multi-vendor, very diverse. You're no longer depending on one company. There's lots of different clouds. There's lots of different Linux distributions. There's many different Kubernetes versions. So the whole story is from single non-virtualized hardware to diverse open source multi-vendor technology. And that's really kind of the history and story of CNCF. If you also kind of look at, I don't know if many of you are familiar with like innovation patterns. We're kind of in the commons period right now. If you kind of look at the history here, virtualization was a huge innovation that really enabled infrastructure as a service and platform as a service, right? It completely changed the game. And then what happened is open source came along and basically introduced a commons period, right? And make this stuff accessible for everyone, basically for free. Containers were also kind of an innovation period, and then CNCF came along and enabled it and made everything available for commons and free for it available. So that's kind of what's happening here. So I get asked, I'm CTO of the organization, helped start the organization, and everyone asks me like, what's happening next in CNCF? What's after Kubernetes? How is Kubernetes going to change? How is the ecosystem going to evolve? And I'm going to try to paint a very biased opinion of how I view things, and hopefully you'll get a little bit of an understanding where I think the future technology direction is and where you may want to invest some time learning technology. So, we went all the way up to 2015. If we start at 2017, there was a very interesting technology pioneered by our web browser friends, the Mozilla folks. They created something called WebAssembly, which is basically enabled to, anytime you open up a new tab in a browser, it creates a new process, and if that process dies, it doesn't kill everything, right? So it was kind of an innovative sandboxing, technology that was created and eventually became an official standard in 2019. I think it was a very interesting technology that will play an important part in the cloud-native ecosystem soon. We eventually went to a point where, in 2018, a lot of you may be familiar with technologies like Amazon Lambda, Azure Functions. These are kind of serverless, but proprietary components. In 2018, Knative was open sourced by Google and contributed eventually to the CNCF. Firecracker was also open sourced by Amazon, which is kind of the lightweight micro VM that powers Lambda. And this is basically, to me, I consider serverless technology starting to move from closed source to more open source options, out there. In 2019, it's been interesting where, I used to be an old Linux contributor 25 years ago, and, it's interesting to see how Linux has evolved, and, Linux now runs in cars, airplane, like everywhere, like phones, every Android phone is running Linux. So, Kubernetes is going through an interesting phase where, Kubernetes was originally built to run in a data center, right, across many, many data centers. People now are putting Kubernetes on embedded devices. I've seen Kubernetes in satellites. I've seen people trying to put Kubernetes in cars, right? It's absolutely a little bit crazy, but in 2019, K3S came around from SUSE, who was kind of the, SUSE Rancher was the original company that came up with this idea. But it was basically, if I want to do an embedded Kubernetes that truly just runs in a lab or embedded thing, then maybe I need to strip out some things, right? Maybe I don't need all these crazy, database drivers. Hey, let's go redo. Maybe we don't need etcds. Let's just use SQLite to store state. So what's happened here is, Kubernetes is being evolved to work in new environments, right? Just kind of like Linux went through the same thing, Kubernetes is going through a very, very similar process where people want to run Kubernetes in different environments. 2019 was a busy year, just before COVID, of course. So definitely a lot of stuff was happening. We also started to standardize observability. So, if you're familiar with writing cloud-native applications, usually you start with a bunch of different microservices. You try to stuff them in containers. You stitch them together. What you really need for this stuff to work at scale is to be able to observe it. So, you could use things like Prometheus or, other technologies to really truly figure out what happens when things go wrong, right? And so in 2019 in CNCF, we had the merger of two two silent observability projects, Open Tracing, which was a CNCF project already, and then we had something called Open Census, which came from Google and kind of focused in a similar space. And we all merged these projects into one new effort called Open Telemetry. It is now the second most active project we have in CNCF and Kubernetes. It is a very critical project. Most observability vendors, including the folks you see in the sponsor hall, I saw Dynatrace, Datadog, and they're all proponents and supporters of open telemetry at the end of the day. In 2021, Linux is, it's very hard to do Kubernetes without Linux, even though you could run, Kubernetes on Windows. But in the Linux kernel, there's been a very important technology called eBPF, which basically allows you to write sandbox, tiny little applications. You kind of think of it that way, or hooks in the kernel, without writing custom kernel drivers, having to reboot the kernel, and so on. And this foundational technology has basically embedded itself in networking projects in CNCF and security projects in CNCF and so on. And so it's kind of becoming a new way to do more advanced networking, observability, and so on. So this is basically a market of maturity that we're seeing eBPF embedded all over the CNCF ecosystem. And if you're new to Linux or still learning Linux, this is a very critical technology to get familiar with. Another thing that happens in 2022 is we have essentially maturity of WebAssembly. So WASI, finally comes out and becomes kind of V1.0 draft, and really kind of enables you to run WebAssembly-based workloads in kind of a cloud-native Kubernetes context. And, I always take it where, Solomon Hykes, there's like a little tweet or X post from him that he said if, WebAssembly and WASI kind of existed when he helped create and popularize Docker, they would have just went and used WebAssembly back in the day because it made a lot more sense for what they were trying to do. So, I kind of view WebAssembly as a new evolution of potentially providing lightweight, efficient workloads for cloud native in the future. So it's 2024. We're about halfway through this year. What's kind of next? So the way I kind of view this is, CNCF is kind of moving up the stack to what we call day two problems. So, in an IT context, like day one is mostly set up the servers, install Linux, install Kubernetes, materialize, things to kind of have the base ready. Day two is more kind of operations. So how do we observe things? How do we secure things? How do we ensure that we could fix things if they fail, right? A good example of day two operations would be, I'm sure people saw in the news the whole CrowdStrike incident, right? There was a big patch. Lots of computers went down all over the world and caused all sorts of issues. That's a day two problem. If CrowdStrike properly used cloud native techniques, they would have never been in this issue. They would have had maybe a progressive deployment, a slow rollout. Maybe they roll out to 1% of the users, smoke test it, and then roll back and fix it. So they messed up, but this is what we kind of really mean by day two operations, is kind of that second bit. And if you look at CNCF, of our 191 plus projects now, we're seeing the day two things more. So for example, cloud cost management, or FinOps, is very popular, right? Because during COVID, if you remember, everyone started to work from home, cloud went through the roof, costs went through the roof, so things got expensive. So how do you manage the cost of these services efficiently was a big problem. So hence, FinOps was born. We have a project in CNCF called Open Cost, which is helping to bring open source techniques to managing cloud costs. We also have something called developer portals. If you're familiar with, we have a project called Backstage in CNCF, which came from Spotify. And the whole idea about a developer portal or Backstage was, hey, we have a lot of services. We need to know who owns them, the SLO, runbooks, all these typical things in one discoverable place. And Backstage helps to do that in an open source way. We're also seeing kind of an evolution of Linux. I don't know if people are familiar with Flatcar, Sidero. There's kind of these, I would say, almost container optimized or cloud native versions of Linux that make it very, very stripped down and simple to run cloud native workloads. So, the whole summary here is like CNCF is, the core is very, very stable. Kubernetes, very mature, very stable. Then the interesting stuff is happening on the layer above: security, observability, developer portals, developer experience, and so on. So that's kind of what, if you kind of go back earlier to my innovation, enablement, and commons bit, I view that, things like K3S, OpenTelemetry, eBPF, or innovative things, along with WebAssembly. With WASI maturing, we're now going to be entering more kind of a, let's call it a commons phase. A lot of open source stuff will be popped up in this thing. So look for that in the future, and hopefully when I give an updated version of this talk, we'll see this pattern play through. So I'll talk a little bit, so that's kind of a bit of history and kind of where I think things are going. I'll talk a little bit more about trends, and then I want to end with how to get all y'all involved in the CNCF and Cloud Native community. So if you look at our project, I recently updated this report. I mean, this is an awful kind of graph to see, but if you go to the GitHub repo, if you go to github.com/CNCF-Velocity, you'll actually see the data and the code there. But if you kind of look at this, Kubernetes is by far the largest project in the CNCF ecosystem. It's overall, I think, #2 in the world behind Linux. And then you have OpenTelemetry, which is very, very large behind this. And then you have kind of everything else that kind of comes along. But this is a very kind of interesting view of like open source project in terms of the overall contributors. And if you're looking to start your career or learn about something that's very, very widely used, this is a good place to kind of do it. And I help publish this. I do it every 6 months. I'll do a refresh on this report. A lot of people ask, hey, what's new in Kubernetes, right? We just had a V1.3.0 release not so long ago. We're getting ready for V3.1.3.1. Really, the biggest thing that I'm seeing in Kubernetes these days is evolutions of how admission control is done, and more importantly, there's something called dynamic resource allocation. I'm sure many of you are familiar with AI technology is gone through the roof recently, right? A lot of people are using AI, whether it's ChatGPT, Claude, et cetera, to do a lot of things. If you look at how people run these services, they're doing a lot of Kubernetes behind the scenes. A lot of containers are involved. And Kubernetes initially, the support GPUs was kind of not great, but now we're investing a lot to improve that with something called dynamic resource allocation. So you see a lot of the recent features in Kubernetes are very much focused on stability, security, and supporting GPUs for AI workloads. In terms of new sandbox and CNCF are always accepting new projects. I'm not going to go into the detail of all these, but a lot of them tend to be focused on either new use cases, improve networking, improve GPU support, and I encourage we all the time are adding new projects to the ecosystem. So what's missing is sometimes that people ask a lot. So if we go back to the history of CNCF, we have an original charter. This was like the original picture of like everything that we should have in CNCF, and basically everything that was in essentially blue or dark blue was what we wanted, right? But in open source, what's amazing about open source is everyone comes together to improve things and bring their own ideas and own use cases, and sometimes your original idea evolves where we host container runtimes in CNCF. We host Containerd, Creo, right? We never imagined to do that a long time ago. We also host software-defined network. We host probably at least 6 or 7 service meshes, Cilium, Linkerd, Istio. There's tons of these. So we evolved with what our community wanted, and so we kind of have this meme now of like, what essentially is part of CNCF, and it's almost like a good amount of what it means to write a modern cloud native application, right? You need to focus on developer experience. You also need to focus how you manage containers, storage, compute, networking. So we're providing options and open source options for everything you truly need to deploy a cloud native application. And if you look at the CNCF ecosystem, a lot of our companies like Red Hat has basically built OpenShift using majority of CNCF project. Rancher is very, very CNCF. So we're providing the tools for both companies, students, and organizations to kind of learn and how to build cloud native applications. We also recently updated what we call what is cloud native when people ask. Well, when you have 11 people in the room for our technical board and try to come up with a definition, it's kind of funny sometimes, but really the most important thing about cloud native when I talk to people is like, really it's all about building loosely coupled systems that essentially interop with each other, that are resilient, observable, and efficient. Really, to me, that is the core of what cloud native is. There's a lot of different ways to implement cloud native, right? You could use, serverless technology, service meshes, there's very different ways, but the core things are, things are secure, resilient, manageable, observable, and so on. So this is something that we update maybe every 2-3 years based on what happens in the community, but it's just something to kind of share with all y'all so you understand. And there's translations in almost every language out there on this, which is super cool. So another thing that's kind of happening with Kubernetes is almost every place I go to, everyone asks me like, what's going on? Like, how does Kubernetes support AI? And I'm like, Kubernetes already runs OpenAI. Every modern AI type thing is using Kubernetes behind the scenes. So I don't know what the question really is here, folks, but really the thing that's going on is Kubernetes is adding improved support for GPUs, observability. There's some interesting problems when you create GPU-based workloads where you want to kind of co-locate them maybe in a little different way that you would do with a traditional application. So Kubernetes is improving its kind of scheduling techniques to support something called gang scheduling, which is a little bit more relevant for AI-based workloads. But there's a whole group of people in the CNCF. If you really care about AI, want to learn a little bit more in cloud native thing, we have an AI working group. If you could scan the QR code, join them. There's very much a large group of people that are working on this problem. So to kind of end things, there are many ways to join our community, right? I've seen some familiar faces here, and sometimes people come to our community through an event like this, or they did a contribution, or they did a mentorship. So I'm going to go through some different ideas for you to potentially participate in our community here. And we'll end things with maybe a couple questions if we have time. So the biggest thing that we really do to kind of help support students coming into our community is we have essentially paid mentorships. If you're familiar with Google Summer of Code, we have a very similar program called LFX Mentoring, which we pair our open source project maintainers with students or mentees to do their first open source contribution potentially to a CNCF project. So we do this 3 times a year. It's a great way to learn how to do open source and also get paid for a few months of your time. It's one of the best things I think we offer and do, and a lot of people that go through this program also end up becoming big-time contributors, maintainers. That usually helps them getting their first job, which is very, very, very cool. The other things we do is things like this. So we have an amazing amount of global event organizers that produce events. We call them KCDs. They're in Lima. We've seen them all over China, Australia, Europe. It's absolutely crazy. I think we've done over 60 of these in the last couple of years. So and the thing that I love about this, it's very regional to the community that's local to the region. So it's very, very cool, and it's good that we're seeing everyone here. And the important thing to note is, to contribute to CNCF, you don't have to just only contribute via code, right? If you're an event organizer, if you're in the marketing, there's many, many different ways you could contribute, here. We also have a group of ambassadors. So I don't think I've seen Edith yet, but she was the one that pestered me to come speak to Lima. So you have her to thank to drag me out here and invite me to this, wonderful, wonderful community. So thank you, Edith, for flagging me down and inviting me. But we have a great community of ambassadors that really serve as local folks that help promote cloud native and Kubernetes in their regions. And we welcome a lot of people to apply and join. A lot of times people ask hey, I know how to program a little bit. Where can I contribute? Generally, I would recommend do a mentorship, or we have a special site called clotributor.dev, which is basically a whole list of issues that are meant for first-time contributors. So it's like fixing docs, maybe writing some examples. So this is a great list of issues if you want to contribute code potentially to a CNCF project. Another way to participate in our community is simply attend an event like this, local, a KubeCon, a Cube Day. So we're doing one in Colombia in October 9th, which is going to be, lovely, covering all sorts of aspects of the cloud native stack. So there's a ton of global events out there that you could contribute. For big events, we also do KubeCons. These are, best way to describe it, it's almost like a massive concert of cloud native nerds. There's 10,000 plus people that show up to these things. And for the next couple of years, we're going to be doing London, Amsterdam, Atlanta, and LA for our bigger events. So I'll wrap things up with some final thoughts before handing it off to the next speaker. We kind of have a saying in open source is, contribution is the currency of open source. The more you contribute, the more you have a say in a project, whether you're an individual or a company. If you look at the research out there, this is especially for companies out there who question of like, hey, Linux is free, or Kubernetes, Prometheus is free, I don't need to contribute. If you look at some of the research done by universities, what they basically show is, if you actually contribute, you get more value out of it, right? Versus someone who completely free rides and just uses the stuff for free. So always consider contributing, because it actually is better for your business at the end of the day. Let your employees, encourage your employees and folks to contribute back. And I was kind of looking at the data of, I was trying to rank Peru overall in terms of countries that contribute to CNCF projects. You were 81, total, which is pretty good for, comparatively to kind of like, essentially starting out your journey. We still have a very young, new cloud native community here. So, hopefully the next time I show up here, there's more encouragement to contributions, so contributions go up. And finally, like I mentioned this before, there's truly many ways to contribute and join our community. You don't have to be an engineer. You don't have to be a computer scientist. You could help organize events, translations, learn how to program, join a mentorship. We have many, many different ways you could kind of contribute here. So please take time. The community is very friendly. Find your local ambassador here, Edith, ask her questions. I'm here for today, so please flag me down, and we're truly welcome everyone to contribute to this wonderful community. And so to kind of end things, we have a special program that we kind of, for people that have truly gone above and beyond and kind of really learn and show off their cloud native skills. We have something called Cubestronauts, and we have a handful of them in Peru and the LATAM. We have 20 in I think like 22 in the LATAM region, and we have 6 in Peru total. So I don't know where everyone's sitting, but I have special little jackets for you that I want to at least give away because I managed to bring them all the way here from the US. But if Angel, Enzo, and Joshua, and Jaime, and I don't think Jack and Miguel are here, but if you're up, can you come up here and I'll get you your little jackets, so to celebrate your, there we go, so perfect. Let's give these folks a hand. Yeah, no. So what they've done is actually not easy. So like I helped create some of the certifications, and if you ever taken a Kubernetes certification, it is very hands-on, very, very difficult. Oh, they want a picture. We'll take a quick little picture, but you're getting cold. Yeah, no, it's surprisingly cold in Peru right now, but it is winter, so I guess it makes a lot of sense. All right. There we go. We'll take a quick picture, and then. So thank you so much. And for people that are interested, it is very difficult. It's a very difficult certification that is a hands-on type of thing, and they've passed 5. So thank you, absolutely, thank you. And if you're very interested, if you kind of want to learn a little bit more about Kubernetes, we have a essentially, this is like the starter. This is 1 of 5. This is like the starter kind of certification and exam that you want to learn to really understand our ecosystem, what we're all about. So there's a special code you could use, and if you kind of search for this, enter the code and you get a free one. So please use that, and hopefully you could learn and become part of our community. And if your skills are really good, you could earn one of those blue jackets. So thank you so much for the time here, and I'm here around basically all day until a little after lunch. And if you have any questions, feel free to message me or find me on Twitter, X, online. So thank you very, very much.
¿Preguntas? No hay preguntas. Entonces, los invito para tomarnos una foto. Vengan aquí. Todos los aquí vamos a tomarnos una foto con Chris y los QB astronautas antes de que iniciemos. ¿Hay una pregunta? Pueden irse acercando para la foto también. Buenos días. Aquí, ¿esto la pregunta?
Sí. Welcome to Peru. God you bless, Mr. Chris. What are you comment on cyber attack of systems Microsoft? The world affecting GPAs, aviation, rates, consequences. Think about Dr. PhD Abel Gutarra, University San Martin de Porres, Monte Rico, Lima, Peru. Thank you.
Mucho gusto. Gracias. Yeah, thank you. All right, let's go. I know, big photo, no get to it. See? Oh, gracias. Okay.
Let's change only with the public.
Okay. Are we good? Good, vamos? Okay, good to see you. All right. Anyway, so I'm happy to answer some questions. So I'm trying to, like, the question I think was around, like, I don't know, it was like Microsoft and, like, my thing is, like, the future of software is going to be open source. And if you're a student, I would definitely spend time learning open source options. Like, Microsoft is still very widely deployed. Even Microsoft supports Linux these days. So, you know, Microsoft still runs a good chunk of the world, but almost every server that serves a website, you know, Apple, blah, blah, all running Linux. So, favor open source solutions. It's easier to learn something where you could pick apart and do. So, okay. All right, I think, what else? Who's going to direct me? I have questions. We could do a couple more. If not, you could find me. Yeah.
Hi, Chris. My name is Eduardo. I come from the .NET C# world. Do I have to be a super hardcore C nerd to contribute code?
So the question was, you know, you're a .NET C# person from the Microsoft ecosystem. So CNCF, there's no one language, right? We have a lot of projects that I would say 80% of them are Golang. So Golang, I think we may have one project that has like C#, but it's a very minor thing. I think getting well versed in Go would be your best avenue to learn, to contribute. But if you already know C#, the learning Go is not to do. It's a lot more reasonable. It's a lot easier from C# to Go than C# to like C or C++. Like just right, yeah, no problem. Any other questions? Otherwise, uno más. Oh, sí.
Well, welcome,
Yeah,
Chris.
yeah.
What do you think about Kubernetes, a key component of modern stack platform engineer?
Yeah.
Why Kubernetes emphasize a lot on security?
Yeah, so I think the question is like, you know, how is Kubernetes a key component of like platform engineering, and why is security emphasized? So the second question's the second part's easier. So like Linux, Kubernetes, if you just download it by default, it's not secure. Like if you just go compile the Linux kernel yourself, it's not going to be configured with like SD Linux and secure. Kubernetes is very similar where, you know, generally what people do is they purchase from a vendor. Like OpenShift could be viewed as like secure Kubernetes, right? Rancher, secure Kubernetes. Or you use, you know, Amazon's EKS, which is their version. So by default, Kubernetes is not secure. You need to like configure it yourself, just like Linux. This is almost like every open source project out there generally won't be very, very secure by default. There's some special things you need to do because if it's secure by default, sometimes it's harder to use. Like it's harder to get started with. So very different. And the first thing, like, so for platform engineering, like, I mean, Kubernetes is basically distributed Linux. It is now the core bit that everyone runs applications on. And I would say, you know, it's similar to like driving a car, right? Like, you know, you don't need to know, you know, how an engine works or how anything works in a car to be successful and use it, but it does help it does help to know if something goes wrong or something's off. Learning the core helps, and so I view Kubernetes as the core bit that drives platform engineering. So learning a little bit about the networking stack in Linux, or how Kubernetes works, what's a pod, how to debug things is useful, but it's not required. So, cool. Awesome. Well, thank you everyone for your time, and hopefully you enjoy the rest of the event. So thanks.
Thank you, Chris. Bueno, muchas gracias para Chris. Vamos a continuar con las charlas.